When wiring stacked convection ovens, certain electrical specifications and safety measures need to be followed. Considering two ovens each rated at 12.5 kilowatts and 240 volts, the combined load amounts to 25 kilowatts. The total amperage is calculated to be 104 amps, which is derived from 104 amps times 240 volts equals 25,000 volt amps. For wire sizing, number 2 THHN conductors are suitable for this amperage. It's important to note that the original answer referenced 250 kc male, that doesn't apply here. Based on the calculated amperage of 104 amps, the next standard size breaker is 110 amps. The manufacturer typically provides the connecting wires that bridge the two ovens together. These wires are often found within a junction box situated either on the rear or side of the oven unit. If you encounter difficulties in locating these connecting wires, firstly, thoroughly inspect the oven's packaging, as the wires may be included inside. Secondly, directly contact the manufacturer for assistance. They can guide you to the location of the wires or provide a replacement set. While the nameplate might not specify the breaker size, the calculated amperage of 104 amps is within the operational range of a 110 amp breaker. It's best practice, however, to confirm specific breaker requirements with the manufacturer to ensure accurate sizing. Several additional considerations are important for the overall electrical setup. Firstly, verify that the electrical panel has sufficient capacity to accommodate the combined load of 25 kilowatts from the two ovens. Secondly, install a disconnect switch in close proximity to the ovens for enhanced safety during maintenance or emergencies. Thirdly, it is recommended to have the entire electrical installation inspected by a qualified electrician. This inspection ensures adherence to local codes, standards, and safe installation practices. It is important to understand that THHN wire is a specific type of building wire. THHN stands for thermoplastic high-heat nylon. It is a common type of insulation for electrical wires in conduit or other raceways. The properties of THHN wire are important in electrical installations. It is heat-resistant, moisture-resistant, and abrasion-resistant because of its nylon coating. THHN wire is rated for up to 90 degrees Celsius in dry locations. This high temperature rating allows it to carry more current than some other types of wire. THHN wire is commonly used in residential, commercial, and industrial applications for branch circuits, feeders, and services. The wire is available in solid and stranded forms, with stranded wire being more flexible and easier to pull through conduit. When selecting THHN wire, it is essential to choose the correct size for the intended application based on the ampacity requirements and applicable electrical codes. Using undersized wire can lead to overheating and potentially dangerous situations. Overcurrent protection, such as circuit breakers or fuses, is essential to protect THHN wire and the electrical system from overloads and short circuits. Proper installation practices, including correct termination and support, are crucial for ensuring the long-term reliability and safety of THHN wire installations. Local electrical codes and regulations should always be followed when working with THHN wire to ensure compliance and safety. Regarding electrical panels are a critical component of any electrical distribution system. Their main function is to receive electrical power from the utility company and distribute it to various branch circuits within a building. Electrical panels typically consist of a metal enclosure that houses circuit breakers or fuses, a busbar system, and various other components. The circuit breakers or fuses protect individual circuits from overloads and short circuits, preventing damage to equipment and reducing the risk of electrical fires. Electrical panels are available in different sizes and configurations to accommodate the electrical needs of various applications. The size of the panel is determined by the total number of circuits required and the expected load on each circuit. Proper sizing of the electrical panel is essential to ensure that it can handle the electrical demand of the building without overloading. Regular maintenance and inspection of electrical panels are necessary to ensure their safe and reliable operation. This includes checking for loose connections, corrosion, and damaged components. Any issues identified during inspection should be promptly addressed by a qualified electrician. The electrical panel should be installed in accessible locations and kept clear of obstructions to allow for easy maintenance and troubleshooting. Proper labeling of circuits is essential for identifying and isolating specific circuits during maintenance or emergencies. Working on electrical panels can be dangerous and should only be performed by qualified electricians who have the necessary training and experience. Safety precautions, such as wearing appropriate personal protective equipment and energizing circuits before working on them, should always be followed. Local electrical codes and regulations should be followed when installing and maintaining electrical panels to ensure compliance and safety. Now let's consider disconnect switches. Disconnect switches are safety devices used in electrical systems to isolate equipment or circuits from the power source. They provide a visible and reliable means of disconnecting power for maintenance, repair, or emergency situations. Disconnect switches are typically installed near the equipment they serve and are designed to be easily accessible. Disconnect switches are available in various types and sizes to accommodate different voltage and current ratings. They can be manually operated or motor operated depending on the application requirements. The main function of a disconnect switch is to provide a safe and effective way to energize equipment or circuits, preventing electrical shock and damage. Disconnect switches are often used in conjunction with lockout-tagout procedures to ensure that the equipment remains energized during maintenance or repair. Proper installation of disconnect switches is essential to ensure their safe and reliable operation. This includes selecting the appropriate size and type of switch for the application, as well as following manufacturer's instructions and applicable electrical codes. Regular inspection and maintenance of disconnect switches are necessary to ensure that they are functioning properly. This includes checking for loose connections, damaged components, and proper operation of the switch mechanism. Disconnect switches should be clearly labeled to indicate the equipment or circuits they serve. Working on electrical systems can be dangerous, and disconnect switches should only be operated by qualified personnel who have the necessary training and experience. Safety precautions such as wearing appropriate personal protective equipment and verifying that the equipment is energized before working on it should always be followed. Local electrical codes and regulations should be followed when installing and maintaining disconnect switches to ensure compliance and safety. An electrician plays a crucial role in electrical installations. Electricians are skilled tradespeople who specialize in the installation, maintenance, and repair of electrical systems. They work on a wide range of electrical equipment and systems in residential, commercial, and industrial settings. Electricians are responsible for ensuring that electrical systems are installed and maintained in accordance with applicable codes and standards. They must have a thorough understanding of electrical theory, wiring methods, and safety procedures. Electricians use a variety of tools and equipment to perform their work, including wire strippers, pliers, multimeters, and conduit benders. They also use specialized testing equipment to troubleshoot electrical problems and ensure that systems are operating safely and efficiently. Electricians must be licensed or certified to work in most jurisdictions. This typically requires completing an apprenticeship program and passing an examination. Continuing education is often required to stay up to date on changes in electrical codes and technology. Electricians work in a variety of settings, including construction sites, factories, office buildings, and private homes. They may work independently or as part of a team. Safety is a top priority for electricians, as they work with electricity on a daily basis. They must follow strict safety procedures to prevent electrical shock and other hazards. Electricians play a critical role in ensuring the safety and reliability of electrical systems in our homes, businesses, and communities. They are essential for keeping the lights on and powering the many devices and appliances we rely on every day. Now let's talk about the National Electrical Code. The National Electrical Code, or NEC, is a widely adopted standard for the safe installation of electrical wiring and equipment in the United States. It is published by the National Fire Protection Association, or NFPA, and is updated every 3 years. The NEC provides comprehensive guidelines for electrical installations covering topics such as wiring methods, overcurrent protection, grounding, and equipment installation. It is intended to protect people and property from electrical hazards. The NEC is not law itself, but it is often adopted by state and local jurisdictions as part of their building codes. This means that compliance with the NEC is legally required in many areas. The NEC is organized into chapters, articles, and sections, each covering a specific aspect of electrical installations. It includes detailed requirements for wiring materials, conductor sizing, overcurrent protection, grounding, and bonding. The NEC also addresses specific types of equipment and systems such as lighting, motors, transformers, and generators. It provides requirements for their installation, wiring, and protection. The NEC is constantly evolving to keep pace with changes in technology and industry practices. New editions of the NEC are published every 3 years to incorporate the latest advancements and address emerging safety concerns. The NEC is an essential resource for electricians, electrical contractors, and anyone involved in electrical installations. It provides the knowledge and guidance needed to ensure that electrical systems are installed safely and in accordance with industry best practices. Compliance with the NEC is critical for preventing electrical fires, shocks, and other hazards. It helps to protect people and property from the dangers of electricity. It is important to have a solid understanding of electrical theory. Electrical theory is the foundation upon which all electrical systems are designed, installed, and maintained. It encompasses the fundamental principles and concepts that govern the behavior of electricity. A strong understanding of electrical theory is essential for electricians, electrical engineers, and anyone working with electrical systems. It enables them to analyze circuits, troubleshoot problems, and design safe and efficient electrical installations. Key concepts in electrical theory include voltage, current, resistance, and power. Voltage is the electrical potential difference between 2 points in a circuit measured in volts. Current is the flow of electrical charge through a circuit measured in amperes. Resistance is the opposition to the flow of current measured in ohms. Power is the rate at which electrical energy is transferred or consumed, measured in watts. Ohm's law is a fundamental principle in electrical theory that describes the relationship between voltage, current, and resistance. It states that voltage is equal to current multiplied by resistance, or voltage equals current times resistance. This relationship is essential for analyzing circuits and calculating voltage drops, current flows, and power dissipation. Series and parallel circuits are two basic types of electrical circuits. In a series circuit, components are connected end-to-end, so the same current flows through each component. In a parallel circuit, components are connected side by side, so the voltage is the same across each component. Understanding the characteristics of series and parallel circuits is essential for designing and troubleshooting electrical systems. Alternating current, or AC, and direct current, or DC, are two types of electrical current. AC is the type of current used in most household and commercial electrical systems. DC is the type of current used in batteries and electronic devices. Understanding the differences between AC and DC is essential for working with different types of electrical equipment. Magnetism and electromagnetism are closely related to electricity. Magnetism is the force of attraction or repulsion between magnetic materials. Electromagnetism is the interaction between electricity and magnetism. Understanding the principles of electromagnetism is essential for understanding how motors, generators, and transformers work. A good understanding of electrical theory is essential for anyone working with electrical systems. It provides the foundation for safe and efficient electrical installations. Let's consider conductor sizing in more detail. Conductor sizing is a critical aspect of electrical installations, as it ensures that electrical conductors are capable of safely carrying the intended current without overheating or causing excessive voltage drop. Proper conductor sizing is essential for preventing electrical fires, equipment damage, and other hazards. The ampacity of a conductor, which is the maximum current it can carry continuously without exceeding its temperature rating, is a primary factor in determining conductor size. The ampacity of a conductor is influenced by its material, size, insulation type, and installation conditions. Electrical codes, such as the National Electrical Code, provide tables and guidelines for determining the appropriate conductor size based on the ampacity requirements of the circuit. These tables take into account factors such as the ambient temperature, the number of conductors in a raceway, and the type of termination. Voltage drop is another important consideration in conductor sizing. Voltage drop is the reduction in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. Electrical codes typically limit the allowable voltage drop in branch circuits and feeders. To minimize voltage drop, it may be necessary to increase the conductor size beyond what is required for ampacity. The type of insulation used on a conductor also affects its ampacity and suitability for different applications. Common insulation types include THHN, THW, and XHHW, each with different temperature ratings and moisture resistance. The insulation conditions, such as whether the conductor is installed in conduit, cable tray, or free air, also affect its ampacity. Conductors installed in enclosed spaces, such as conduit, typically have lower ampacities than conductors installed in free air due to reduced heat dissipation. When sizing conductors, it is important to consider all applicable factors and consult the relevant electrical codes and standards. Using undersized conductors can create a fire hazard and damage equipment, while using oversized conductors can be unnecessarily expensive. Proper conductor sizing is essential for ensuring the safe and reliable operation of electrical systems. Overcurrent protection is also very critical for electrical installations. Overcurrent protection is a critical safety measure in electrical systems that protects conductors and equipment from damage caused by excessive current flow. Overcurrent protection devices, such as circuit breakers and fuses, are designed to automatically interrupt the flow of current when it exceeds a predetermined level. Overcurrent can occur due to a variety of reasons, including short circuits, overloads, and ground faults. Short circuits occur when there is an unintended low resistance path for current to flow, resulting in a large surge of current. Overloads occur when the current in a circuit exceeds the rated capacity of the conductors or equipment. Ground faults occur when current flows through an unintended path to ground, such as through a person or a metal enclosure. Circuit breakers are electromechanical devices that trip and interrupt the flow of current when an overcurrent condition is detected. They can be reset manually after the fault has been cleared. Fuses are single-use devices that melt and break the circuit when an overcurrent condition occurs. They must be replaced after they have blown. Overcurrent protection devices are selected based on the ampacity of the conductors and the rating of the equipment they are protecting. Electrical codes, such as the National Electrical Code, provide guidelines for selecting the appropriate overcurrent protection devices. Overcurrent protection devices must be properly installed and maintained to ensure their reliable operation. They should be tested periodically to verify that they are functioning correctly. Overcurrent protection is essential for preventing electrical fires, equipment damage, and electrical shock. It is a critical component of any safe electrical system. Now let's dive into grounding and bonding of electrical equipment. Grounding and bonding are essential safety practices in electrical systems that provide a low impedance path for fault current to flow back to the source, allowing overcurrent protection devices to quickly interrupt the circuit. Grounding is the connection of electrical equipment and systems to the earth, providing a common reference point for voltage. Bonding is the connection of metallic parts of electrical equipment and systems to create an electrically conductive path. The purpose of grounding is to limit the voltage on electrical equipment and systems to a safe level, preventing electrical shock hazards. Grounding also helps to stabilize the voltage during normal operation and provides a path for lightning strikes to dissipate safely. The purpose of bonding is to create a low impedance path for fault current to flow back to the source, allowing overcurrent protection devices to quickly interrupt the circuit. Bonding also helps to minimize voltage differences between metallic parts, reducing the risk of electrical shock. Grounding and bonding are typically achieved using grounding electrodes, grounding conductors, and bonding jumpers. Grounding electrodes are metal rods, plates, or other devices that are buried in the earth to provide a connection to ground. Grounding conductors are wires that connect electrical equipment and systems to the grounding electrode. Bonding jumpers are short lengths of wire that connect metallic parts of electrical equipment and systems together. Electrical codes, such as the National Electrical Code, provide detailed requirements for grounding and bonding electrical systems. These requirements specify the size and type of grounding and bonding conductors, as well as the methods for installing them. Proper grounding and bonding are essential for ensuring the safety of electrical systems and preventing electrical shock hazards. They are critical components of any safe electrical installation. And finally, consider regular inspection and maintenance of electrical systems. Regular inspection and maintenance of electrical systems are essential for ensuring their safe and reliable operation. Electrical systems should be inspected periodically by qualified personnel to identify any potential problems or hazards. Maintenance should be performed on a regular basis to keep electrical equipment and systems in good working condition. Inspection should include checking for loose connections, damaged wiring, corroded components, and other signs of wear and tear. Maintenance should include cleaning, lubricating, tightening connections, and replacing worn or damaged parts. Electrical panels should be inspected for proper labeling, secure connections, and signs of overheating. Circuit breakers and fuses should be tested to verify that they are functioning correctly. Grounding and bonding systems should be inspected to ensure that they are intact and providing a low impedance path for fault current. Electrical equipment, such as motors, transformers, and generators, should be inspected and maintained according to the manufacturer's recommendations. Regular inspection and maintenance can help to prevent electrical fires, equipment failures, and electrical shock hazards. They can also extend the life of electrical equipment and systems. A written record of inspections and maintenance should be kept to track the condition of electrical systems and to plan for future maintenance activities. Electrical systems should be inspected and maintained in accordance with applicable codes and standards. Proper inspection and maintenance are essential for ensuring the safety and reliability of electrical systems.